All right, let's jump right in. Have you ever really stopped to think about the ground you're standing on, or the mountains, or the coastlines? We see them as permanent, right? But the truth is, the Earth's surface is in a constant slow-motion battle, being broken down, carried off, and rebuilt somewhere else. Today we're going to follow a single rock on that incredible journey.
Yeah. It's so easy to think of the Earth as this solid, static thing. But it's not. Not at all. It's a dynamic, restless place. And to really understand how it works, we're going to follow the life story of one of its most basic building blocks.
So, meet our main character, a huge, solid piece of bedrock. Looks pretty tough, doesn't it? Timeless, unbreakable, like it's been right there since the dawn of time. But believe me, it's about to start an epic adventure that will completely transform it.
And that brings us to the big question for this whole explainer. What could this massive, solid rock possibly have in common with a tiny grain of sand on a beach hundreds of miles away? The answer is pretty much everything. One is the before, and the other is the after.
So, the first chapter in our rock story is a breakup. It's a process called weathering, and it's the relentless first step in reshaping the entire planet.
The whole thing really boils down to 3 key steps, which you can see right here: weathering, erosion, and deposition. A really easy way to remember it is the acronym WEED. We're starting with the W for weathering, which is basically the break-sit phase.
So, weathering is literally just the process of breaking down big rocks into little rocks. But here's the key thing to remember. It happens in situ. That's just a fancy term that means it happens right on the spot. Nothing's moving away yet. This is just the demolition phase.
And it's not just wind and rain doing the heavy lifting. You know, life itself is a huge part of this. We're talking tree roots acting like wedges, slowly prying rocks apart. You've got burrowing animals digging around and exposing new rock surfaces. Even decaying plants can release weak acids that slowly eat away at minerals. And yup, humans get in on the action too, every time we plow a field.
Okay, so once weathering has done its job, our rock is broken into smaller, weaker pieces. It's vulnerable. And now, a new force enters the stage, one you absolutely cannot escape: gravity. This is where the story can get really dramatic.
This next process is called mass movement, and it's exactly what it sounds like: a large mass of material moving downhill. The one and only force driving this? Gravity.
Now, this is a super common point of confusion, so let's clear it up right now. Mass movement is not the same as erosion. With mass movement, gravity is the only actor. It's a direct pull, like a rock falling off a cliff. With erosion, which we'll get to in a sec, there's a getaway driver, a transporting agent like a river or the wind that carries the material away.
And of course, scientists have a name for everything. You can see here there are a ton of different types of mass movement. You don't need to memorize all this, but the basic idea is that they're categorized by how the material moves. Does it flow? Does it slide? Or does it just fall? Maybe the simplest way to think about it is just speed. Some of these movements are incredibly slow, taking years or even centuries. Others are terrifyingly fast and sudden. We're talking landslides, mud flows, avalanches. But whether they're slow or fast, they're all powered by gravity.
So our rock has been broken apart, and gravity might have even given it a little shove downhill. But now, the real long-distance journey begins. This is where erosion takes center stage.
And we're back to our handy WED cycle. We've done weathering, breaks it. Now it's time for the E for erosion. This is the part where nature takes it.
The big idea with erosion is transportation. It's the process where some kind of natural force with a lot of energy physically picks up those pieces of weathered rock and starts carrying them away on a journey.
So, what's doing all the carrying? Well, geologists call them the agents of erosion. The number one agent by far is running water. Rivers and streams are like massive conveyor belts for sediment. But you also have wind, giant glaciers that act like bulldozers, and of course, the relentless pounding of ocean waves on the coast.
Okay, so our rock has been shattered and then carried away, maybe for hundreds of miles. But that journey can't last forever. Eventually, the ride has to stop. And when it does, something amazing happens. New land starts to get built. So let's look at our WE diagram one last time. We've covered weathering, which breaks it, and erosion, which takes it. Now for the final act, D for deposition. This is where nature drops it.
And really, deposition is just simple physics. When that river slows down or the wind stops blowing, it loses its energy. It can't carry all that heavy sediment anymore. So what does it do? It just drops it. That's all deposition is.
And the result is breathtaking. Look at this landscape. Every single hill, lake, and plain you see here was created when a massive glacier melted and just dropped all the rocks and dirt it was carrying. This process isn't just about destruction, it's also about creation.
So that's the whole epic story. Weathering breaks it, erosion takes it, and deposition drops it. That simple three-step cycle is responsible for carving canyons, building river deltas, and shaping the entire world we see around us. It's how you get from a solid rock to a sandy beach. And here's a final thought for you. This massive, planet-shaping process isn't just happening in some remote, exotic location. It's happening all around you, all the time. The cracks in the pavement, that's weathering. The dirt washing down the street after a heavy rain, that's erosion and deposition. This epic cycle is everywhere. The only question is, where will you see it next?